Hello and welcome to ChemTube. My name is Chakube Paul, your chemistry teacher on this platform. In today's lesson, we would be looking at the second part of the nature and changes of matter. In the first part, we looked at physical and chemical properties with examples, and we also looked at physical and chemical changes. We defined them, we gave examples, and we compared them using some factors such as reversibility, formation of a new substance, mass change, and heat change. In today's lesson, we would be looking at states of matter, and we would also be looking at how these states changes with respect to a given matter. For example, how water changes from one state to the other. Then we would as well be looking at the heating and cooling curve. The heating and cooling curves, because these curves we shed more light on how these transformation from one form or state to the other occurs. Okay, so at the end of this lesson, it is expected that you would be able to differentiate the three states of matter that we would be talking about, and then be able to tell how these changes from one state to the other occur. That is the basic objectives of today's lesson. To start, we define states of matter. States of matter refers to the distinct forms, the different forms that matter can exist in. The forms in which matter can exist in. Because when you see different matters, like we bring water, we bring a loaf of bread, and we bring helium gas, you definitely be able to tell that one is in solid form, the other in liquid, and the last one in gaseous form. These are three different forms. Okay, to even simplify it further, when you bring ice, you bring water, liquid water, and then you try to boil that water and you get the vapor going up. You see water existing in three different forms. One as ice, the other as liquid water, and the last one as water vapor. That is to say that at this level, matter exists in three forms: as a solid, as a liquid, and as a gas. Now we would go ahead and look at the attributes of matter as a solid, as a liquid, and as a gas. So we put down solid here, liquid here, and gas on this side. Okay, let's assume this is a container, this is another container, and this is also another container. This contains solid particles. and this contains liquid particles. And this contains gaseous particles. Okay. So, in solid state, matter has its particles closely bound together because of the significant force of attraction between them. They are what? In contact, strong contact. And as a result of the contact, they are immobile. The only form of movement that solid particles make is vibration around a fixed position. Solid particles can vibrate around a fixed what? Position, but they cannot move about freely. And because of the strong force of attraction that binds them together, it is very impossible for you to compress solid. You can break it, but you cannot compress it. Another factor or another thing that must be said about solid is that solid tend to have a fixed shape and a definite volume. Fixed shape and definite volume. So, let's just put down the first one. Strong force of attraction. Definite shape. Definite volume. Vibrates around a fixed point. And then lastly, we can say that solid particles have very small kinetic energy. Very small kinetic energy. While for the liquid, we can say that it has medium force of attraction. Liquid particles tend to have a medium force of attraction. That is why some of them are what? In contact. But the level of contact is not as strong as that between solid particles. And because of this, liquids tend to be compressible to some extent. There's a difficulty in compressing them, but they can be compressed to a certain degree. Okay? Then liquid tends to have what? Indefinite shape. Indefinite shape. Okay? But a definite volume. In terms of shape, liquid tend to take the shape of whatsoever container that you place it in. For example, if you place it in a rectangular container, it will take the shape of a rectangle. If you place it in a circular container, or let's say a spherical container, it will take the shape of a sphere. Likewise, if you put it in a cylindrical container, it will take the shape of a cylinder. Okay, then in terms of movement, particles of liquid tends to do what? Move about to a certain what? Degree. They move freely to the point of being able to collide with the walls of the container that it is placed in. But this movement is to a certain level. Then lastly, we can say it has a considerable kinetic energy, and that is the reason why they are able to make the movement to the degree that they do, unlike the solid particles. Now, in terms of gas, okay, for gas, the force of attraction is negligible if it exists. But in most cases, it is zero. Zero or negligible force of attraction. Then number 2, it has an indefinite shape. Number 3, also indefinite volume. Number 4, free random movement of the particles. That is to say that gaseous particles tend to have high degree of mobility, unlike the other two. I mean, when you compare it to the other two, it has a high degree of mobility. And this high degree of mobility is as a result of it having a strong kinetic energy. The particles of a gas tend to what? Have strong kinetic energy that facilitates the movement. Is that clear? In terms of shape, gas doesn't have a definite shape. That is why it can occupy the entire vessel that it is placed in, and can even diffuse from one place to the other at a very fast rate. Okay, now when we talk about change in state is brought about by the level of energy contained by the particles of a given matter. Now, in terms of energy, there is an increase of energy in this direction. That is, solid tends to have lesser energy compared to what? Liquid, and liquid lesser energy compared to what? Gas. Okay. Now, if we talk about change in state, let's not talk about change in state. We have solid, liquid, and we have gas. Okay? When a substance changes state from liquid to gas, it is known as evaporation. But when a substance changes state from gas to liquid, it is known as condensation. In the case of solid and gas, when a substance changes state from solid to gas by bypassing the liquid phase or liquid state, it is known as sublimation. And then when it changes state from gas to solid, it is known as deposition. Deposition, which is usually in the form of crystals. Now, when a substance changes state from liquid to solid, it is known as freezing. While when it changes state from solid to liquid, it is known as melting. So, this is how matter changes states. This is how matter changes states. And with respect to that, there is a need to define some points or temperatures. For example, we have the freezing point, we have the melting point, and we have the boiling point. These temperatures are very important. At the freezing point, liquid tends to transform to solid at the particular temperature. That is, freezing point is the temperature at which liquid matter changes into what? Solid matter. Then, melting point is the temperature at which solid matter changes form or state into liquid matter. Then, boiling point is that temperature at which liquid starts to transform into what? Vapor or gas. Okay, now having said this, let's take a look at heating and cooling curves. Like I said earlier, these curves tends to show us how change in state occur, how change in state takes place. That is what these curves tend to tell us. So, to illustrate it, I'm going to use the heating and cooling curves of water to show you how these changes in states takes place. Okay? Let's say we have temperature on this side, which could be in degree Celsius or degree Kelvin. And here we have what? Time, which could be in seconds, minutes, or hours. But for the sake of this, let's put it in seconds. Okay? And let's say this is 0 degrees. And we have 100 degrees somewhere here, and then 110 degrees somewhere here. Now, at 0 degree, water is in solid form. Water is in solid form because 0 degrees is the freezing point or freezing temperature of water. When water gets to 0 degree, it begins to what? Freeze. And when it is at 0 degree, it is frozen. But when the temperature starts rising, there is a change in state. So, let's say heat is applied to water. When heat is applied to water, there is a rise in temperature with time. So we have something like this. But the increase in temperature does not necessarily make the ice to melt until the melting temperature is attained. So let's say this is the melting temperature. At this point, this is melting point. So at this point, what happens is that ice begins to melt. But when the melting point is attained, further heating or further introduction of heat to the system does not yield a rise in temperature. No. That is why we have something like a flat point or flat curve. Now, at this point, water is in the form of ice, which is what? Solid. It's in the form of ice, which is solid. But when it gets to this melting point, what happens? That solid begins to melt. So at that particular point, what we have is solid plus liquid. That is ice plus, let me write water here. So we have solid plus liquid at this point. Now, this temperature remains constant until all of the ice has melted. When all the ice melts, what happens? Further heating leads to what? Increase in temperature. So we have something like this. Okay? So let's put this here and let's put this here. So at this point, what we have is just water, which is what? Liquid state. Because when this temperature starts increasing, it means that what? There is no more ice. All we have is now water. So while it remains in liquid state, the temperature keeps increasing with addition of heat. Now this continues until we get to what? Until we get to the boiling point. This is known as the boiling point, or temperature at which water boils. So when it gets to this boiling point, what happens? Further addition of heat does not yield an increase in temperature over time. So what we have is something similar to this flat curve. Now, we have a flat curve here. And at this particular point, what we have is water plus water vapor. Because at the boiling point, water begins to transform into gas, which is what? Water vapor. So what we have here is now L plus what? G. L plus G. That is what we have there. So this temperature remains constant until all of the water, liquid water, has transformed to what? Water vapor. And at that point, when you continue heating it with time, what you now have is what? Water vapor alone. This is now water vapor. Okay, water vapor, which is gas. So this is how energy affects change in state, from solid all the way toward gas, with increased what? In heat, which reflects on the temperature of the system. Is that clear? Is that clear? Okay, now let me ask you a question. Let's assume substance X. Substance X at 23 degrees is, okay, at minus 23 degrees is in solid state, and at 210 degrees is in gas state. Okay, now at 85 degrees, what is its state? That is, this substance X is in what state at 85 degrees centigrade? I'd like to get your answer in the comment section. Now, to wrap up what we have just talked about, the three basic states of matter has been looked at, which is solid, liquid, gas. We looked at their properties side by side. We talked about changes in states. And lastly, we looked at heating and cooling curves using water as example. This is where this lesson comes to an end. If you have any question, you can get across to me through my email address or through the comment section. If you are just joining us for the first time and you want to continue with us, you can do that by subscribing to the channel and as well clicking on the notification button so that when we have new video, you will be notified of it. This is where I bring today's lesson to an end. Thank you very much and have a nice day. Bye.